Hi friends, let us prove some basic statements in trigonometry ratios. We have 1 by secant square alpha minus cos square alpha plus 1 by cosecant square alpha minus sin square alpha times cos square alpha into sin square alpha equals 1 minus cos square alpha sin square alpha by 2 plus cos square alpha sin square alpha. Right. So in the right hand side, everything is in terms of cos alpha and sin alpha. Here we have secant and cosecant, cos and sin also. So let's try to convert everything into cos and sin. Right, secant square alpha minus cos square alpha. Secant square alpha is 1 by cos square alpha. Right, cosecant square is 1 by sin square alpha. Let's write this as is. Just replace secant square with 1 by cos square and cosecant square with 1 by sin square. Then what will this become? This part will become 1 minus cos power 4 alpha and cos square will come to the top. This is cos square alpha by 1 minus cos power 4 alpha. And similarly, this one will become 1 minus sin power 4 alpha and sine square alpha will come to the top, right? Sine square alpha by 1 minus sine power 4 alpha whole times cos square into sine square alpha, cos square sine square alpha, right? So far, so good. Now, this denominator 1 minus cos power 4 alpha, this we can write it as, this is in the form of a square minus b square, a plus b into a minus b, we can write it. That is 1 minus cos square alpha into 1 plus cos square alpha. Similarly, 1 minus sine power 4 alpha, we can write it as 1 minus sine square alpha into 1 plus sine square alpha, right? A square minus b square, a minus b into a plus b, right? And this cos square alpha, sine square alpha, let it be as is, right? Now, what is 1 minus cos square alpha? This is sine square alpha. So, this part will become cos square by sine square into 1 plus cos square. This part will become sine square by 1 minus sine square is cos square. Sine square by cos square into 1 plus sine square, right? Into cos square alpha, sine square alpha. Now if you do this multiplication, this sine square and this sine square will cancel, right? Then this becomes cos square alpha by 1 plus cos square alpha. So cos power 4 alpha by 1 plus cos square alpha. If we do this multiplication, similarly, here this cos square and this cos square will cancel, and this part will become sine power 4 alpha by 1 plus sine square alpha. That's what it has become, cos power 4 by 1 plus cos square, sine power 4 by 1 plus sine square. Right. Now, let us do the cross multiplication. Cross multiplication, this, if we take the LCM, 1 plus cos square into 1 plus sine square, and cos power 4 into 1 plus sine square, plus sine power 4 into 1 plus cos square. Right. And let us just expand this. Let us do the multiplication and expand this. Cos power 4 plus cos power 4 sine square alpha, sine power 4 alpha plus sine power 4 cos square alpha. By this is 1 plus sine square alpha plus cos square alpha plus sine square cos square alpha. Alright, just let's do the multiplication also. Here we have sine square plus cos square. So this becomes 1. So 1 plus 1 will become 2. 2 plus sine square alpha cos square alpha is the denominator. Right, that is this. Now, in the numerator, if you see, there is this cos power 4 alpha, there is this sine power 4 alpha. Let's bring them together. And then there is cos power 4 sine square and sine power 4 cos square. Let's take cos square sine square common from this term and this term together. Then we'll be left with cos square alpha sine square alpha into cos square plus sine square alpha from these two terms, right? This is, we have cos power 4 and sine square. If we take cos square sine square here, we will be left with cos square. Here, similarly here, if we take cos square sine square, we will be left with sine square. So these two terms we can write it as like this. So, but again, cos square plus sine square is equal to 1. So this we can ignore. So we'll be left with cos power 4 alpha plus sine power 4 alpha plus cos square sine square alpha. This is anyway 1. Right. Now, if you see these two parts, this is in the form of a square plus b square. Right, where a is cos square and b is sin square. This what we can do? We can rewrite this as a square plus b square. We can write it as a plus b whole square minus 2ab. Right. So let's do that. So this part let's write it as a plus b whole square minus 2ab. That is cos square alpha plus sin square alpha whole square. Here is cos square, right? Plus sin square alpha whole square minus 2 cos square sin square. Right. And this cos square sin square is anyway there, let it be. So this part is again 1. Right. 1 square is again 1. 1 minus 2 cos square sin square plus cos square sin square. So this becomes 1 minus cos square also alpha sin square alpha. That is this. That is the numerator. And denominator is as is. Denominator we already reached. Right. We just need to manipulate the numerator. That's how we have manipulated. and we have proved this. Right, guys? Let us look at one more. We have sine power 8 minus cos power 8a equals sine square a minus cos square a times 1 minus 2 sine square a cos square a. This is pretty straightforward. We have this in the form of a square minus b square, where a is sine power 4 and b is cos power 4. What is a square minus b square? A plus b into a minus b. So this we can write it as sine power 4a minus cos power 4a into sine power 4a plus cos power 4a. This again is in the form of a square minus b square, where a is sine square, b is cos square. So this we can still write it as sine square minus cos square into sine square a plus cos square a, which is anyway equal to 1. So this part has become this. Right. Now this part, this is in the form of a square plus b square. A square plus b square, we can write it as a plus b whole square minus 2ab. Right. A is again sine square, b is again cos square. Right. So this we can write it as a plus b whole square, sine square plus cos square whole square minus 2ab, minus 2 sine square cos square. Right. This part is again anyway 1. Right. Sine square plus cos square is anyway 1. Pythagoras identity. Right. So this is 1 minus 2 sine square cos square, which is what we wanted, this part. And left part is anyway sine square minus cos square. So this is what we wanted to prove, and here it is. We just need to split this into, identify this in the form of, this is in the form of a square minus b square. Right, guys? Let us look at one more. We have cos a cosecant a minus sin a secant a by cos a plus sin a equals cosecant a minus secant a. Basically, everything we have to convert into cosecant and secant. We have cos, we have sin here, but we have to convert everything into cosecant and secant. Right. So let's do that. Cos, let's write it as secant. Cos, we can, this becomes cosecant by secant, because cos is 1 by secant. Right. This becomes secant by cosecant. Right. Sin is, cosecant is 1 by sin, or sin is 1 by cosecant, right? By this also, let's write in terms of secant and cosecant, 1 by secant a plus 1 by cosecant a. Right, if you do the cross multiplication, this becomes cosecant square a minus secant square a by secant a cosecant a. This becomes cosecant a plus secant a by secant a cosecant a. These two denominators will cancel, and this is in the form of a square minus b square by a plus b. Right, a is cosecant a and b is secant a. So a square minus b square by a plus b, which is a minus b, which is what we wanted to prove. Cosecant a minus secant a. Pretty straightforward, guys. Okay, let's look at one more. We have to prove tan a plus secant a minus 1 by tan a minus secant a plus 1 equals 1 plus sin a by cos a. If you look at this, what is this? This is 1 by cos a plus sin a by cos a. What does it mean? This is actually secant a plus tan a. Right, this part is actually secant a plus tan a. So we have to figure out a way to remove all of this. They remove this denominator and this one also, and be left with only these two terms. Right, this is just equal to secant a plus tan a. Right. So what we do, let's try to eliminate the denominator. How do we eliminate? We want, so there is this one, right? This one, let's write this one as secant square a minus tan square a, or Pythagorean identity, right? Secant square a minus tan square a equal to 1, like sin square a plus cos square a equal to 1, right? So this one, let's write it as secant square a minus tan square a. So then this becomes secant a minus tan a into secant a plus tan a. Right. Now we have this tan a plus secant a here and tan a plus secant a here also. Let's take that common. So this becomes tan a plus secant a into 1 minus secant a, 1 minus secant a plus tan a. Right. So please note the signs. Please be careful here. This is secant a minus tan a. So it becomes 1 minus secant a plus tan a, because we are opening the bracket. Right, we are taking this tan a plus secant a common. Right, this basically, this part means tan a plus secant a into 1. So here tan a plus secant a into secant a minus tan a. So that's why if we take this common, this becomes tan a plus secant a into 1 minus secant a plus tan a. This is what the denominator is also. Right. So this is minus secant a plus 1 and plus tan a. So these two can cancel each other. So we'll be left with tan a plus secant a, which is this again, right? This is tan a is sin by cos plus 1 by cos, which is equal to 1 plus sin a by cos a. Right, guys? Pretty straightforward. Just that we need to understand the trick, that to use this one and try to eliminate the denominator. Right, guys? We should do a lot of practice. Then these things become very easy. Now, let's do one more thing. we have tan alpha plus cosecant beta whole square minus cot beta minus secant alpha whole square equals 2 tan alpha cot beta cosecant alpha secant beta. Basically, we have alpha and beta, two different angles. Right, we have tan and secant and cosecant and cot. Right, tan alpha, secant alpha. We know secant square minus tan square equals 1 alpha and cosecant square beta minus cot square beta is equal to 1. The familiar Pythagorean trigonometric identities we know. Let's try doing that. Right, let's expand this. This becomes a plus b whole square. Tan square plus cosecant square plus 2 tan cosecant beta. Sorry, 2 tan alpha cosecant beta. Tan square alpha cosecant square beta plus 2 tan alpha cosecant beta. Similarly, this becomes minus cot square plus sine square a minus b whole square, right? Minus 2 cot beta secant alpha, right? Let us open this bracket. Then this becomes minus cot square minus secant square plus 2 cot beta secant alpha minus cot square beta minus secant square alpha. Let's gather this tan square and this secant square together. Right, tan square minus secant square. Then let's gather this cosecant square and cot square. Cosecant square minus cot square. Then 2 tan alpha cos cosecant beta plus 2 cot beta secant alpha. These ones. This one and this one. Those are these two terms. Right. Now what is tan square minus secant square? We know secant square alpha minus tan square alpha equals 1. So tan square alpha minus secant square alpha is minus 1. So this part is minus 1. Then this part, cosecant square beta minus cot square beta, this part is anyway 1. Right, this is 1. So these two will anyway cancel. Then 2 tan alpha cosecant beta plus 2 cot beta secant alpha. Right. So these two things, this entire part is cancelling, is getting cancelled. Right, and this is minus 1 plus 1, this is getting cancelled. We will be left with these two terms only. Basically, these two terms only. These two terms we have to convert into this format. Right, we have tan alpha is fine. We have to get cot beta and cosecant alpha. Right, we have to get cot beta and cosecant alpha. And here, right. So what we do, this one, let's write this cosecant beta as 1 by sine beta. 1 by sine beta, and here what we have extra 2 cot beta secant alpha. Secant alpha, we want secant beta here, right? So what we do, um, tan alpha, let's keep it like this. Cosecant beta, let's write it as 1 by sine beta, and just multiply by cos beta with both numerator and denominator. Right, why we are doing this? We want a cot beta, right? This is basically equal to 1, but just because we want a cot beta, let's try doing this, right? Then this becomes cos beta by sin beta, this becomes cot beta. 2 tan alpha cot beta into 1 by cos beta. That means secant beta plus 2 cot alpha. Again, secant alpha is 1 by cos alpha. Here again, we want sin by cos, which is tan alpha, right? We want, so that's why let's multiply with sin alpha, both numerator and denominator. So this part becomes tan alpha cosecant tan alpha into cos by sin, right? Tan alpha into this cos by sin. Cos by sin is cot beta, right? And cos beta is secant beta plus this sin by cos. This becomes tan alpha, cot beta to cot beta, sin alpha by cos alpha, which is tan alpha, and this 1 by sin alpha. This becomes cosecant alpha, right? Now we have cot beta and tan alpha is there in both places, which is what we wanted. That's why we multiplied with these two things and these two things. Right, let's take this common 2 tan alpha cot beta into secant beta plus cosecant alpha, which is what we wanted. Secant beta plus cosecant alpha. This is the statement we wanted to prove. Right, guys? Simple ones. Hope you like this. Thank you.